Here we just want to take the whole concept of being able to find the intersection points, and we're, instead of doing two lines, we're going to be doing two quadratics. Still the same thing. Whenever you have something in function notation, it's talking about y equals. And here it's y equals. So the first step we did is once they were solved for the same variable, we just took the other parts of that equation and we set them equal to each other. So let's just go right there. So I have negative x squared plus 2x plus 6 is equal to x squared minus 6. Alright, well, going to our rules of quadratic, if this was linear, we try to group the x's on one side and throw everything else on the other. But now that we have quadratic, remember what we have to do is we have to have 0 on one side and everything else over. So we want to move everything to one side. So if I subtract an x squared, and then if I subtract 6, add 6 because I'm moving it over, what we're going to get is a negative x squared and negative x squared is a negative 2x squared plus 2x and then plus 12 equals 0. Alright, so now I've got to factor it because it looks like we're going to have the intersection points, not just a point. First rule of factoring, let's see if everything's common. Looks like there's a negative 2 I can pull out. That'll leave me with x squared minus x minus 6. And to finish factoring, we'll get x and x, a negative 3, a positive 2. And let's finish this on out. So you would go negative 2 equals 0, x minus 3 equals 0, and x plus 2 equals 0. Well, that front one with the negative 2 equals 0 is not really giving us anything because there's no variable involved, so we just throw it out. With this next one, it's telling me x equals 3, and then x equals negative 2. Alright, well we just found part of the coordinates, but now we have to go back and find the y values that go with these coordinates. So I would say let's go to the g of x equation, this one right here. That one was simple, but it just says take any x value and square it and then minus 6. And you would have gotten, you're going to get the same y value either case. I'm just going to go with the more simpler equation. So for this one, when x is 3, then y is going to be 3 squared minus 6, which is 3, right? 9 minus 6 is 3. And for this other x value, then we're going to get y to be negative 2 squared minus 6. So 4 minus 6 is negative 2. Alright, so here are my coordinates. My intersection points are 3, 3 and negative 2, negative 2. And there's my overall answer, just like that. Okay, so kind of one of the last topics we're going to talk about is equilibrium. Equilibrium is a very specific price that a company needs to set their product at so supply equals demand. Okay, we know break even. Break even is when cost equals revenue, so the money in equals the money out. But what equilibrium is all about is when supply equals demand. It means it's very important for a company because it means if I want to be able to put just as much items on the shelves as what will be taken off the shelves. Because for a company, when you think about it, they're losing money if they put stuff out there on the shelves and people aren't buying it, especially if they're perishable goods. And so for a company, it's very important to know, all right, what's that magical number to where if I put out there, 2,500 items, then I know the public is going to want 2,500 of these. And in reference to all that, you also have a very specific price because it's not only do you want to be able to just put the items on the shelf, you have to price it at that magical number so that way the demand equals the supply. All right, so taking those concepts, let's go to example number 11, which is number 25, and let's look at number 26 in the book on page 130. Okay, what I'm really going to do is, since they're both kind of the same problem, why don't we just look at just number 25. So I'm going to ignore 26. It's just the exact same thing. So we're just going to focus on one of them. But what's happening here is what you're given is, this is a demand equation where x is the quantity demanded. So over here, the x variable is the quantity demanded. And it's all, remember how I told you, it's all with respect to the price? Because our public, they're not going to want to buy stuff off the shelves until they know the price of it. So this is very much a function of the price, okay? And specifically they want us to do is that they want us to sketch the supply curve and then determine the price. I'm sorry, I'm reading the wrong one. We want to sketch the demand curve and then determine the quantity demanded when the price is specifically $11. Okay, so let's do the curve. We're going to graph this equation. Okay, and remember our x-axis, and then we have a y-axis, but in this case it's not y, it's p. And looking back to the problem, it says P is units of just dollars, where X is actually in units of quantity demanded in units of thousands. Okay, so if we wanted to graph this, just when X is 0, so when I'm focusing on quadrant 1 mainly because if X is the amount of thousands of items, that's, you can't ever do a negative of them, so it's got to be at least positive. So if I plug 0 into that equation, then we get 6, 12, 18. Let me just get some of these. How would we go by, what if we go by tens? So if X is 0, 0 squared 0 plus 36, so 10, 20, 36 right there. Okay, let's think of another number. How about if I plug in 6? Okay, so if I sell 6,000 items, if I plug in 6, 6 squared is 36 and becomes negative, so negative 36 plus 36 is 0. Very interesting, huh? Now, if this was linear depreciation, we would just draw a straight line down, but we don't. We have a quadratic equation. Let's see real quick. I'm just going to go over to the side work because I'm just curious. Let's see what we can do as far as the vertex. Where's this curve going? Okay. Well, the x value of your vertex is negative b over 2a. So it's going to be, the x term is 0 over 2 times negative 1. So it's going to be 0. And then the y value, when I plug in 0, it's going to be 0 squared plus 36. So it's definitely 36. So what we just found out is this is actually the high point. So it's just going to be a curve kind of coming down there. It would actually probably finish out that way and then come back that way as well. Okay. But it's definitely coming down as a curve. So there's the graph specifically. And then the problem further asks us to say in part B is determine the quantity demanded when the price is set at $11. Okay, so at $11, that's our price. So P is equal to, we want to find X because remember X is the amount demanded. All right, so let's move 36 over. So 11 minus 36 is going to give us negative 25. Divide off that negative 1 coefficient. So 25 is equal to x squared. And then to remember, get x by itself, we're going to take a square root, and we always do plus or minus. So x is equal to 5, and x is equal to negative 5. Okay. Well, word problem. Let's interpret this answer. Remember, X is the amount that's demanded. So when we set the price of this product at $11, then what it's saying is not just 5 items are demanded, but 5,000 are demanded. Can you demand a negative 5,000? Not so much. So in word problems, we're going to throw out the negatives. So what we can say as at the price, or at the $11 price, 5,000 items are in demand. And that's exactly what we just found. Okay? So here's an example of graphing the curve where just paying close to, instead of y equals, it's p equals, because price depends on the amount of demand. If demand goes down, then they sometimes they lower the price, so that way people want to buy them off the shelf, or they put them on sale, things like that. Right, let's try this again. Let's go to another example. Okay, I just wrote out some things just real quick for us. They gave us 2 equations. The first equation is the supply equation. And so P is equal to negative 2x squared plus 80. And then they gave us a second equation, which is the demand equation. Okay, now look, both of these are P equals. So both the supply is dependent upon, it's a function of basically the price. And the price still depends on the items demanded or the items supplied. Okay? So P is always the price. It's always very flexible. It's going to depend on how much is demanded to how much is supplied. Okay? And in this question, what they want us to do is they want us to find specifically what quantity will supply equal demand, and then what's that price that we have to set it at. Okay? So in other words, let's find the equilibrium. Equilibrium is when supply equals demand. And anytime you're going to set 2 equations equal to each other, the first thing you want to know is make sure are they set for the common variable? Well, it's P equals all of this and P equals all of this, so we're ready to set it up. So supply specifically is negative 2x squared plus 80. demand is 15x plus 30. So let's keep solving this out. I have a quadratic because I have an x squared term. So let's move everything over to one side. I think I'm going to move it to the right this time just so my x squared is positive. So I'll go 0 is equal to a positive 2x squared. Let's see, f plus 15x. And then I'm going to have 30 minus 80, so minus 50. Let's see if we can finish solving this. So 2x and x. I want the factors of negative 50. And it looks like I probably want a 10 and a 5. 10 times 2 is 20. So I want that positive and that one negative right there. Okay, so setting them each, coming out of this one, we'll get an x value. By the time I move the 5 over, it'll become positive and divide by 2. And over here, I got an x value of negative 10. And remember, x always represents the quantity, so we can't really have any negatives. So it looks like x is going to be 2.5. Going back real quick, x represents the quantity demanded in units of thousand. So really, this interprets 2.5 is 2,500. Okay? So to answer the question, it says, first of all, what is the equilibrium quantity? So the equilibrium quantity is 2,500 items. And the equilibrium price, meaning what needs to be on that label in order for us to sell exactly supply equaling demand, just go back up into any one of those two equations. Let's go 15 times, and I'm going to take the x value as is, so 2.5. I'm not going to do the 2,500. That was me interpreting it into the units of thousands. Okay, so 15 times 2.5 plus 30. And that will give us a price then of $67.50. Okay, and I would have gotten the exact same thing whether I used the supply equation or the demand equation. All right, so to interpret this again is in order to find the equilibrium, you just go supply equals demand and solve for x. Once you get that x value, you can plug it back into either equation and actually get the price that goes with it. So you're a customer, you go up to a shelf, and you see that thing is priced at $67.50, you're going to take it off the shelf. Think of it maybe as an iPad. That'd be kind of cool. All right. And what we've just found for the company is that as long as they supply 2,500 of these, then all those consumers out there that there's only going to need, all they're going to need is 2,500. In other words, there's not going to be one person out there going, oh man, I wish I got that. Too bad they're sold out. And like the other way around, there's not going to be a consumer out there walking by going, yeah, that's still too pricey for me. I think I'll wait. It's that nice, happy little medium where if I put 2,500 on the shelf and I price it at $67.50, then everything's going to be taken away and not one person wishes they had it. So it's very, very important to know this equilibrium when it comes to business. All right, let's try this again with example number 37.